The question says, why is Wurtz reaction not preferred for the preparation of alkanes containing odd number of carbon atoms? And further it says, illustrate your answer by taking one example. About Wurtz reaction you might have learned it is used to prepare symmetrical alkane. And how is that reaction? Let me write it. Let's say alkyl halide is there, alkyl halide, and we have sodium is there, sodium, and one more molecules of alkyl halide we take, alkyl halide, and here we have the acetone as a solvent. Okay, so you can see one halogen, no, one sodium can combine with one halogen. There are two halogen. So we do one thing. I write this alkyl halide in this form. Mention alkyl halide this side. This is X and it is R is there. Okay. So two halogens are there. We take two sodium and this portion is eliminated from here. So we got 2 Na and it is X, and we got alkyl group attached. So this is what symmetrical alkane is there. Symmetrical alkane. And symmetrical alkane will always carry even number of carbon. Okay. So Wurtz reaction is preferred for the preparation of a symmetrical alkane having even number of carbon. Now question arises here. It says why it is not used for the preparation of alkanes having odd number of carbon. Okay. So in general, if you can see this is alkyl halide and it is also alkyl halide, and in this chemical reaction whatever the alkyl halide I have taken here, same alkyl group, yeah, same alkyl halide should be taken here also. Yet two molecules of alkyl halide are taken and both alkyl halides should be same. Okay, if I take methyl chloride, it should also be methyl chloride. If I take propyl chloride, it should also be propyl chloride. Then this reaction works very well. Okay, but if I take it is methyl chloride and I make it ethyl chloride, number of carbon are different, then situation will change. In this case what happens, let's say if I take CH3, this is Cl. Okay, one carbon, we take sodium is there, and here we have C2H5 and it is Cl is there, and here we have the acetone. Okay, acetone is there. So if I do not take same alkyl halide, different alkyl halide, and then I try to prepare the product formation will be there. Definitely this reaction will take place. But in this case what happens exactly, these alkyl halide they will react with each other, but apart from this they will start reacting with itself. Okay, this molecule will react with one more molecule of CH3Cl, one product will be possible. This molecule will react with one more molecule of the C2H5Cl, then one more product is possible. This molecule will react with this molecule, then one more product is formed. So in this reaction you can see, apart from reacting these two substances with each other, they start reacting with themselves. This is the reason we get mixture of alkane. Okay, see how this reaction takes place. First of all, following this chemical reaction, we complete this reaction. You can see two alkyl halide are there, two halogens are there. I take two sodium. Okay, so one Cl, another Cl, two sodium. So what will happen? Two NaCl is separated from here, and then we get CH3, and it is C2H5 is there. C2H5. Keep in mind this is not symmetrical alkane. Okay, because if you break it from here, so this side we have only one carbon, this side we have two carbon are there, this side we have two carbon. Okay, this is not symmetrical alkane. This is one product is possible, but other than this you can see one molecule of this substance will reacting with but the same molecule. So what will happen, if I take CH3, it is Cl plus Na plus CH3, it is Cl. So 2 Na you can take, this portion is segregated, so again we get the product CH3, it is CH3 is there. So one product will be what, CH3 is there. Okay, in this case done, this molecule will start reacting with itself. So again we get C2H5 Cl plus Na, same process, Cl and it's C2H5, take two molecules, this portion is segregated. From here we got C2H5, so we got another product C2H5 and it is C2H5 is there. This is symmetrical, this is also symmetrical. Two symmetrical alkanes are there and one unsymmetrical alkane is there. Mixture of alkane, you can see we are getting mixture of alkane, and again segregating these alkanes from the mixture is further tedious task. Okay, in this case getting only one type of alkane, that is a symmetrical alkane having even number of carbon in the product. Odd number, even number, even numbers. So mixture of alkane is produced, if we take different alkyl halide in the reaction. So this is the drawback for the Wurtz reaction. Okay, that's why this reaction is much more useful for the production of symmetrical alkane having even number of carbon, If you like this video, please share and subscribe to the channel.